Okay, question 20 here of paper 1 of Churchill Maths. This question is all to do with inequalities, part A and part B. So if this is a question that you found difficult, then obviously you need to go and do a little more revision on inequalities, on drawing inequalities on a number line, and solving inequalities. If we look here, total marks for question 20 is 3 marks, so it means that we don't have to do too much thinking. It's going to be straightforward, either we know what we're doing or what we don't need to do. So these are easy marks to pick up in the exam. If we just look at question 20A to start with, we have here at -2 a circle here that's open, and at question number 7 we have it closed here. Now the first thing you need to understand is that with inequalities is that you have these symbols like this, okay, which means that this number on this side is greater than that side, so it means 3 is greater than 1, but that also could be written as 3 is greater than 1 that way, as long as the end that's open is going to the number that's bigger. Now with each of these here, we would use an open circle because it means it's not equal to. So if we looked at a question like this where we had 3 is greater than or equal to x, then what that means is that the number 3 on this side is greater than or equal to whatever the value of x would be. That means x can't be 4 because then that means 3 wouldn't be greater than it. So it means x can be either 2, 1 or 0. Now what we also know is that it can be equal to it because of this little line here. So it means x could also equal 3 as well, because 3 can equal 3. So when we have it with a little equal sign, it means this bit is coloured in. So the easiest way to approach questions like this, if I can just clear my annotations here, is to look at it again and say, right, there's an open circle here, so it's -2. We've got a closed circle here at 7. X is all the numbers that can be in between it. Okay, and therefore x is going to be less than 7, but because it's coloured in here, that means we can be equal to, so it means x could be 7, but it could be 6, 5, 4, 3, 2, 1, and on this side here it means x must be greater than -2, but it can't be equal to -2, so x could go down as low as -1, and then it would have to stop. So where it says write down the inequality represented by a diagram above, we've already done that. So -2 is less than x, or x is greater than -2, depending on how you interpret, and x must be less than or equal to 7, or 7 is greater than or equal to x. So that's part 1 done. Now if we look at part B here, it says we need to find the whole number n, given that 2n is smaller than 30. So all I need to do is simply treat it like an equation. I divide that side by 2 and divide that side by 2. Which then means that I'm going to get n is less than 15. So that means that n is any number less than 15, so it can be 14, 13, 12, 11, but it can't be equal to 15. And on this side here, because I've got 3 lots of n, I just divide by 3 to get 1 lot of n. And therefore, if I do that, I get n is greater than, now 40 divided by 3 is not always an easy number to do. Okay, so but if I do my bus stop method there, so I'm dividing by 3, so there's 40, put my decimal point, put a couple of zeros just in case. 3's in the 4 go 1, remainder 1. 3's in the 10 go 3, remainder 1. 3's in the 10 go 3, and as you can see it will just reoccur. So therefore n is greater than 13.3 reoccurring. Now if we look at this now, it's saying that n must be smaller than 15, but it must be greater than 13.3. So if you think of your number line here, where I put 13, what we're saying is at this point here we have 14 here because it says it must be a whole number, and 15 here. And what we're saying is n must be less, okay, than 15, but it must be greater than, say, 13.3, which means the only whole number it could be is 14. So therefore, find the whole number n given that 2n is less than 30 and 3n is greater than 40, it means that n must be equal to 14. Okay? And that's your easy 3 marks. Thank you for listening.